Hey guys, I'm going to do what I normally do for review where I summarize all of the content to help you with your note cards, but I'm going to do it on video since I'm not going to be there. We're going to start with inverse. Okay, and 4.1 is inverse. And this part's really basic. You're going to switch x and y, and then you solve for y. Pretty simple. If you have f at x equals, let's say, x plus 1, remember that the f of x is essentially your y. So I rewrite it with the y in place of it, and then I switch. X equals y plus 1. And then you solve for y. So I'd subtract 1 from each side. If x minus 1 equals y. And then what you have to remember is to use inverse notation. Okay, so once I've done this, then I say the inverse function is x minus 1. Okay, make sure that you use that notation when you solve your problem. Okay, so that's inverse. Now, I'm going to do exponential and logarithms next to each other so you can kind of compare as you go. So I'm going to start with exponential functions. That's 4.2. Functions, there we go. And this is where you have y equals b to the x. Okay, and for your critical points, our original critical points are 0, 1, and 1b. Okay, and this is different. If you watch the old videos, this is different from the way the videos did it, but it's a lot easier. So pay attention to this. Your asymptote is going to be horizontal. And it's always y equals whatever your k is. Okay. And then, actually, yeah, y equals whatever your k is. And I'm going to redo this up here so that I've got x minus 1 plus k. Okay, so that we remember that that's where the k is, or x minus h, sorry, plus k. And then your parent function looks like this. Oh. Okay, before you do any flipping or moving, it goes like this, and it always goes through 0, 1. Okay, so I'm going to do one with an example. If I gave you y equals 2 x plus 4 to the x plus 4 minus 3. Okay, the x plus 4 tells me that's your h, and it goes left and right. This is going to go left 4. This tells me my k, and that means it's going to go down 3. Okay, so if I look at my original points, your original critical points, remember, are 0, 1, and 1 comma b. My base here is 2, so I'm going to use 2. My translated points are when I do the left 4 and down 3. Left 4 means I'm going to subtract 4 from my x's. So that's going to be a negative 4 for this one. And 1 minus 4 is a negative 3 for this one. And down 3 means I'm subtracting 3 from my y's. So this is 1 minus 3 is negative 2, and 2 minus 3 is negative 1. So those are my translated points. My asymptote is going to be y equals my k, so y equals negative 3. When I go to graph this, and this is just a rough graph, but that's okay. I know my y is a negative 3, so I'm going to come down here to get my asymptote. Don't forget to draw your asymptote, and it's horizontal. Okay, and my translated points are negative 4, negative 2, and negative 3, negative 1, and this shows that it's going generally in that direction. Okay, my domain is always going to be negative to positive infinity, and my range on this one goes from negative 3 to positive infinity, and I want you to notice the negative 3 is the asymptote. Okay, so I did that there, and I took up, what I'm going to do on the other side is do my log functions. So 4.3 are logarithmic functions. Whoops. I love when it does that, don't you? Okay. It's like you're in the classroom with me. Logarithmic functions. Okay, in this one, you're going to have y equals the log base b of x minus h plus k. Okay, and the same thing where h goes left and right and k goes up and down. For this one, our original critical points are going to be 1, 0 and b1. Notice these are exact opposite of the exponential ones. And our asymptote is going to be vertical, and it's going to be x equals h. Again, inverses of what we did before. The parent function of a logarithmic looks more like this because of the vertical asymptote. So if we use an example of y equals the log base 3 of x plus 3 minus 4, this tells you that I'm going to go left 3, and this one tells you that I'm going down 4. Okay, because remember, x is always lies, so the h always goes the opposite direction. My original points would be 1, 0 and 3, 1, because my base is 3. My translated points are going to be, again, I'm subtracting 3 from 1, so that's negative 2. Subtract 3 from 3, that's 0. And 0 minus 4 is negative 4 for my y's, because that's my k. And 1 minus 4 is negative 3. My asymptote, remember, is x equals whatever my h is. My h is the opposite of that, so it's negative 3 because x is always lie. Okay, and I draw this. This time my asymptote is vertical through negative 3 because it's a log function. My 2 points are going to be 1, 2, 3, 4, are negative 2, negative 4, and 0, negative 3. So it's going to kind of curve up this way and down this way. My domain is from negative 3 to infinity. And again, that's based on my asymptote. And my range for this one's always negative to positive infinity. And so I did those side by side so you can see the differences and make sure that you don't mix those up. Okay, so that's 4.2 and 4.3. 4.4 is the one that tripped you guys up on your mini quizzes. And these are log properties. Some of them did. Okay, so first is condensing and multiply, or condensing and expanding. Plus and multiply go together. So log base b of x plus log base b of y is going to equal log base b of those two things multiplied together. Subtraction and division. I'm going to have log base b of x minus log base b of y equals log base b of x over y. Notice it's not log of x over log of y. It's one log of that fraction. Make sure that's in parentheses. And then the last is when we have exponents and coefficients. So I have x log a equals the log base b of a, base b of a to the x. And basically, if you're going in this direction, you're condensing. And if you're going in this direction, you're expanding. Okay, so that's the rules for that. Then we have solving logs. Okay, the first type of solving, we have 3 types of solving logs. The first one is if the variable is in the exponent, you need to inverse the log of the base on both sides. So my example of this is if I have e to the x minus 2 equals 40. Okay, my variable is in the exponent. My base is e, so my inverse of that is natural log. And what that does is that allows me to inverse the e and get rid of it. So now I have x minus 2 equals the natural log of 40. This natural log on the right side didn't undo anything, so we're keeping that. I'm going to add 2 to both sides. And x equals the natural log of 40 plus 2. This is the exact answer in exact form. And if you put it in your calculator and solve it, and you round it to the hundredths, I get 5.9, and this is my estimated value. Make sure you label whether it's exact or estimated. Okay, so that's one kind. Go to the next page. The next one, the next kind of situation is if the equation has 2 single logs equal to each other, drop the logs. So if I have the log of x plus 2 over 3 equal to the log of x minus 1, I can drop the logs, and now I've got x plus 2 over 3 equals x minus 1. I'm going to multiply both sides by 3 to get rid of the fraction. So I've got x plus 2 equals 3x minus 3 because I'm distributing that 3. I'm going to get all my x's on one side and my y's on the other. So I'm going to subtract x to move it over to the right. I'm going to add 3 to move it to the left. You guys are smart. I'm doing 2 things at once. So I have 5 equals 2x. Divide by 2. And my x is 5/2, or 2.5. And you can use a decimal if you can have an exact decimal. You don't have to round it. Okay, the third situation is if the log is only on one side, we do the around the world. So that's if I've got log base 3 of 2x minus 1 equals 3. This is where I take the base to the exponent equals the argument. So I would have 3 to the third power equals 2x minus 1. 3 to the third power is 27 equals 2x minus 1. I'm going to add the 1 to both sides, so 28 equals 2x minus 1. And then when I divide both sides by 2, I know that x is 14. Okay, so those are the 3 different situations I want to make sure that you know about. Okay, that moves us to another part of 4.4, and that's evaluating logs. Oops. Okay, and if you have a log base b of y equals x, this is the around the world thing, b to the x equals y, that's going to become b to the x equals y. Okay, and on these I'm looking for a common base. If you don't show me the common base, you're not going to get full points. So you get a common base and then set the exponents equal to each other. Okay, so if I have log base 16 of 4 equals x, I'm going to do the around the world. So 16 to the x equals 4. Okay, and then I want them to be written as a common base, and usually that common base is whatever the smaller number is. So if my base is 4, to rewrite 16 as a base of 4 would be 4 to the second. That means I have 4 to the 2x equals 4 to the 1. Now that I've got common bases, I can set my exponents equal to each other. So 2x equals 1, divide both sides by 2, and x is 1/2. Okay, so that's the common base. The other way we can do it is a change of base. Make sure you pay attention to if it says change of base or not. If the instructions say change of base, then you have to use the change of base. And that's where we take log base b of y. And since we can't put anything but a log 10 in your calculator, we make it into a log 10. And we make this the log of the argument over the log of the base. So my example would be log base 3 of 11 becomes the log of 11 over the log of 3. That would be my exact form. And when you put that in the calculator and round it, I get 2.18. That would be my estimated. Make sure when you have exact and estimated, you label which one's which. I'm going to be looking for that. Okay, and the last thing we've got is our interest. Let me do that right. 4.5 is interest. Okay, and we've got 3 formulas. We've got, the main ones are where we compound periodically, and that's A equals P times 1 plus R over N to the NT, and compound continuously. And you'll know the difference because compounding continuously will have the word continuous in the problem. And that's going to be A equals principal times e to the RT. Okay, for compounded periodically, remember that annually, my n is 1, monthly, my n is 12, weekly, my n is 52, quarterly, my n is 4, and daily, my n is 365 even in a leap year. And then for both of these, the parts are the same. A is your final amount. P is your principal. That's your starting amount. R is your rate as a decimal. N is the number of compounds per year. And I listed those out to the left there. And T is the number of years. Make sure if you have months that you convert them back to years. And the last one, our favorite one, is the annuities. That one that makes you rich. Okay. And it's A equals P times 1 plus R over N to the NT, all of that minus 1, and all of that over R to the N, R over N. Whoops. And just remember that this P is your monthly payment. And last but not least, make sure you're never rounding till the very end. And that's everything you need to know for your test. I'm really sorry I couldn't do this in person, but I will see you guys on Wednesday.